Hey folks, in this video I want to introduce the idea of a runtime execution environment. So before we've been talking about APIs and talking about system calls. So what happens when you make a call? Okay, so I have basically this diagram here, right? We have kind of a new thing being introduced, the idea of a system call interface, right? So the system call interface is sort of composed of your API plus a gateway to actually get you to the things that implement your API. So let's look at the diagram for a second. The programs that you write are things like this, the user application. In this example, it's calling the open function. So we call open. Open is a system call, right? It's something that maybe is opening a file. I don't know how to, I need somebody that has access to the hard drive to do this. What happens? So from your perspective, you make a call to open and stuff just happens. What happens in the back end though? So your open call is basically being given to the system call interface, right? So the system call interface is basically the thing that's responsible for actually executing that. So when your program is running, there is something they call runtime, runtime environment or runtime library. Basically, there has to be some code loaded up to take care of these different pieces of functionality, for example, open. So what happens here? So we start basically in our program, right? Our program is in what they call user mode, right? So this is stuff that basically it's unprivileged code that can run and do things, but it's maybe a little bit restricted. It's like for code you don't really trust, right? Then you also have kernel mode code, which is below it, which is things that basically it's the operating system, right? The operating system is allowed to do anything, right? Your code isn't allowed to do anything, but the operating system is. So your program is running, you make a call to open. So you go through the interface. What the interface actually does is it has this lookup table, right? So this is a table over here. And in this table, this is basically I would say it's a table of functions. So this is basically a list of, here I would have open, I would have close, I would have write, I would have read, etc. Right? I have all these different things there. So this table in memory is basically saying, oh, the user wants to run open, what should I do? It goes basically and finds what is the appropriate thing, right? So here I want to do open. And so open, right, is something that basically is known, right? It's one of the features that my API is providing. And so I actually go and I look at the OS and say, okay, you need to run open, right? And so this over here, this is basically, actually just a little bit different. So that's a function that the OS contains internally, and that's the code behind the scenes, right? And so your program basically, so you want to run open. You go say, so you want to run open. You start by going to the interface and say, I want to run open, right? The interface looks at this table and says, oh, he wants to run open. Where does open exist? Oh, open's over here. Goes to where that thing is stored, and then runs that program code, right? So there's kind of this loop here of you go from your program to requesting something to figure out where is the support for that. Once you know where the support is, you run the code, and then you go back and you give the result back to the user, okay? So there's this cycle here, right? Basically, I'm going somewhere else and asking it to run code for me. And there's this kind of lookup table behind the scenes because maybe your environment can change, right? So maybe you're on a different computer, right? There's going to be a different table saying, oh, open leads here, right? So maybe there's a different implementation, right? This is implementation, v1, right? Maybe there's also implementation of open v2, right? So there could be another implementation of this code somewhere else. And your table could be updated at some point, right? To be like, oh, use this one instead, right? Your table basically is providing this level of indirection where it's like, well, the user wants to run open. Where can I find the code for open, right? Maybe it's over here. Maybe it's over here, right? It could come from different places, right? This would be important for us, right? If we were doing things like, for example, supporting patching, right? So I want to update and maybe have a different version of open running, right? That type of thing. All right. So this is kind of our overall view. So there's a question for you guys here. You can think about it for a second. Why not bake the code for system calls right into the executable? Right? So notice over here, we kind of deferred this actual implementation. Why not just take this code and copy it over there? Take 1 second and think about that. Well, the simplest reason is because something could go, well, there's two reasons. The simplest thing is that something could go wrong, right? Maybe I can't open up the file correctly because I don't know how the hard drive works, or maybe somebody else is trying to open that file at the same time, right? That's stuff that basically the OS is the only one that's going to know enough to be able to handle, right? So the OS is going to know all the programs that are running. It's going to be able to say, oh, hey, someone's writing or someone's reading from that file already. I'm going to make sure you don't open it right now. I'm going to make you wait, right? The OS is the only one that has kind of that bird's eye view of what else is happening in the system. And so basically, right, so there's kind of the idea of, well, that's information only the OS would know. There's also a sense of opening a file is maybe something that should be like a special operation. Like I don't want any program to be able to open any file, right? Because then it's like, well, I have, I download a file from the internet, I click it, it's able to open up the passwords folder on my computer and then transmit my passwords to somebody else, right? That is not okay, right? I should have basically specific permissions to do specific things. Well, if you have permissions, somebody needs to manage the permissions. Oh, that means you're talking about the OS, okay? So that'd be another reason. Oh, and also the other one is the updating reason. So if I want to basically have a newer version of Open that maybe fixes some bugs, it would make sense that instead of combining that code into my executable, I have it basically factored out. It's in a different place. Somebody else basically can update that different place, and when I go to run it, right, I'll run that updated version, right? So bug fixes is another reason. All right, so that's all I got for you guys in this video. This is kind of an introduction to how that runtime environment works. Basic idea is I have kind of this indirect way of calling a function that the OS is providing.